sure this is turned on. Okay. So we're looking for increasing, decreasing. So 19, we would say f of x. Gosh, I hope I didn't give you f of x's tomorrow. I'm going to go ahead and prepare this, 2x minus 3 for the derivative. But how do we find this domain? We're going to set 2x minus 3 equals 0. And we're going to get x equals 3 halves. We're not allowed negatives. So when I do negative infinity to 3 halves and 3 halves to infinity, give me a test value. 0. And now we're going to test 2x minus 3. 0 minus 3 is negative. 4 minus 3 is positive. So my next step, my domain is 3 halves to infinity. All right. So now we're going to do the derivative. What rules involved here? Why isn't it product? 24 doesn't have a variable. So we take half of 24 times this to what power? Negative 1/2. And the derivative of the inside is 2. And the derivative of 6x is 6. So we're going to end up with 24 all over the square root of 2x minus 3 minus 6. Yes?
Do you always have to set up that table?
If you don't need it to get the domain correct, no.
But,
And in the beginning, yes, because we were preparing for today, or this unit. Why? Because it was an even root, and even roots have negative issues, and negative issues require tables. Does that make sense? Only negative issues. Yes?
Why is it a bracket at 3 halves?
Because that was not in the denominator. So we can square root 0. All right, so now when I do this over 1, I'm going to get 0 is equal, just kidding. I'm going to add 6. That looks more like a bug. All right, I'm going to add 6. And see, I like these problems better than what the book wrote because the book, it came out to be nothing. But you see here we have something. Now what? So that means 6 square root of 2x minus 3 equals 24. How do you go about solving this? Right, you've got to isolate the radical. 2x minus 3 is equal to 4. Now what? Square both sides, so I get 16. Add 3, divide by.
Oh, you couldn't have made an even number.
Do you know how hard that is? It is, at least it's halves. You don't know how long I sat there. Sometimes it's taken me an hour to write one of these problems. Doing it and doing it to try to get something that is not too nasty. So, yeah, sorry about that. All right, is there a denominator in my derivative? Yes. That means f prime of x is undefined where? X equal 3 halves. And is 3 halves in our domain? Yes, it is. Will it be in our table? What? Yes, everything that's undefined must go in the table. Question is, even if it's not, it has to go in the table because if it's an asymptote, the increasing, decreasing behavior could have changed on each side of that asymptote. And I do a dotted line to help me remember. All right, so here we go. What are we doing? We're doing negative. No, we're not doing negative infinity. What are we doing? Where does my domain start? So we're doing 3 halves to 19 halves and 19 halves to infinity. Test value? 10. All right, so now my derivative is 24 over the square root of 2x minus 6 minus 3 minus 6. So if I put 2 in, what's 2 times 2? What's 4 minus 3? So what's 24 minus 6? Okay, if I put 10 in, what's 12 subtract 3? What's square root of 9? What's 24 divided by 3? Oh, it's 20 minus 3. 17. Square root of 17 is 4 point something. So 26 divided by 4 is 6. 26 divided by something bigger than 4 is going to be less than 6, so this will be negative. Which means that my f of x is increasing and then decreasing. So you would tell me f of x is increasing on the interval 3/2 to 19/2 because f prime of x is positive. And you would say f of x is decreasing. I didn't ask for max or min, did I? From 19/2 to infinity because f prime of x is less than 0. Yes, sir. Logan.
Can you not plug anything into the table that's not a thing?
Correct.
Okay.
So if you did negative infinity to 3/2 and picked -2, that's a clue something's wrong.
Okay.
Yes, sir.
If there's an undefined slope, that means it's a vertical line, right?
Right.
So can you not have a max or min on an undefined slope?
You can, but the problem with this is that it starts at 3/2, so there's nothing to the left of 3/2.
Yeah, but I mean, like, on the other one.
No, you can, because you can have the bird function. See, there's the bird function.
Oh, that.
I forget what that one is, but that's the bird function. Sharp turn. Maybe it's like x squared minus 4 or plus 4 in the denominator.
I mean, like, when we're explaining the max and min, are we ever going to...
You might have to say that f prime of 2 is undefined. Correct. All right, next question. Number 20. Is it just the derivatives that are the issue or the whole process? I'm going to do a mean value theorem before you all go. So we've got h of x is going to be x plus 3 over x minus 1. And again, I put minus 9x to make it interesting. What's our domain? Positive 1, right? And then 1 to infinity. What rule do we use for our derivative? So we're going to say x minus 1 times the derivative of the numerator, which is minus the numerator times derivative of the denominator, all over your denominator squared. What's the derivative of 9x? 9. So I'm going to say 0 equals x minus 1, distribute minus x minus 3, all over x minus 1 squared minus 9. So what do I have in my numerator? Negative 4 over x minus 1 squared minus 9. Now what are we going to do? We're going to move 9, so I'm going to have 9 is equal to negative 4 over x minus 1 squared. Now I'm thinking this might be a problem. I'm not going to be able to square root this. No, it's going to be negative. I know, but it'll be negative. My question to you...
Oh, I have a negative 9, and then I just subtracted the 9, so it's negative 4 divided by negative 9.
Was the function to start with plus... Okay, because this is probably my sloppy copy. All right, which means now this is negative. So now this is negative. So x minus 1 quantity squared is going to equal 4 ninths, right? And when you square root, well, how many values do you get? Plus or minus 2/3. If you only get 1, you've just lost a bunch of points because your table is going to be half the table. You're going to have half the intervals for increasing, decreasing. So this is going to be x is equal 1 plus 2/3, and x is going to equal 1 minus 2/3. You got to split this up to do that. 3 over 3, that's going to be 5/3. 3 over 3, that's going to be 1/3. Now, where is this derivative? Undefined. X equal 1. All right, is it a critical number? Negative infinity to 1. No, it's not a critical number, but does it go in your table? Yes, it does. Must go in the table because it is an asymptote. And I like to dot it to help me remember that, oh, that is not a dotted line. Start over. I like to dot it to help me remember that that is an asymptote. So what do we have on the top? We've got negative infinity. I think 1/3's the smallest. Then 1/3 to 1, and then 1 to 5/3, and then 5/3 to infinity. Test value? I like that. Test value? Half, maybe? Test value? Test value?
Yeah, it can't be 2. Yeah, no, it could be 4/3.
Okay, 4/3. What about this?
2.
All right. Now, because I have to, x minus 1 squared, even though the denominator is negative, never negative, I've got that plus 9. I've got to figure this out. This is going to be negative 1 squared, which is 1. Negative 4 divided by 1 plus 9 is positive. Now, when I do a half minus 1, I get 1/2, right? Negative. Squared is a positive 1/4. Negative 4 divided by 1/4 plus 9 all of a sudden makes this negative 16 plus 9, or what? Negative. So 4/3 is going to be something similar. 4/3 minus 1 is 1/3. And then when I flip it, it's going to be negative 12 plus 9, which is negative. 2 minus 1, this is going to be positive, which means our function is increasing, decreasing. Can you go from there? Are we good? Did I square the 1/3? Probably not, so that made it even bigger. Well, negative infinity to 1/3, and then 5/3 to infinity. And it's decreasing here, but you got to list them separately because of that asymptote. We need to do a mean value theorem. Now, I'm writing this problem off the top of my head, so I just want you to be aware that this might be a really ugly, ugly problem. What if I told you, I don't want F. What if I told you m of x is x squared minus 3x plus 4? And I want the interval. Oh, this is the problem. Let me think. How about 2 to... I guess it really wouldn't matter. Let's do easy numbers. 1 to 4? Or what about negative 1 to 1? Would that work? No, we'll do negative 1 to 2. All right, so what do we do first? Domain. What's our domain? Okay, what does that tell me then about m of x? That means it's continuous on the closed interval. That's points. Now, what do we do next? The derivative, right. So the derivative is 2x minus 3. Is that derivative, is that always differentiable?
Yes.
So we know m of x is differentiable where? Open interval. I'm checking your parentheses and your brackets. So now we're going to say what? No. Slope of secant equals slope of tangent. What's the slope of the tangent line? 2x minus 3. How do I get slope of secant line? I'm going to need m of negative 1. Square negative 1 plus 3 plus 4 looks to me like it's 8. So I've got negative 1, 8. Now I've got to do m of 2. That's going to be 4 minus 6 plus 4. Is that 2? So I've got 2, 2. So how do I... Did I do that wrong?
It's negative 2.
But 4 plus 4 is 8.
No, the slope. The slope's going to be negative 2.
Oh, you're way ahead of me. Okay, so yes, he just went to where we need to go, and that would be the slope of the secant line is going to be 8 minus 2 over negative 1 minus 2, or 6 over negative 3, or negative 2. And where do we put this? All right. So what we should do here is we should say mean value theorem applies right after our differentiable. All right. So now remember it says find C. So where does C go? In for x. So we have negative 2 equals 2c minus 3. You're going to add 3, and c is 1/2. Now what if you needed the y value? you're going to have 1/4 minus 3/2 plus 4, or 1/4 minus 6/4 plus 16/4, or 11/4. So at 1/2 11/4, the slope of the secant equals the slope of the tangent on that interval.
What are those fractions?
So what I was doing m of 1/2. So I think you should keep this review to study from. Would you agree? Okay. I will post the answer, not only the answers, but the work with it. Yes. You do the derivative. Is there a variable in the denominator? So it's differentiable. What if it had been 2x minus 3 over x? Where 0 is an issue. Is 0 in my interval? Then the mean value theorem doesn't apply. Please go back and look at mean value theorem tabular form. You're telling me because the sign changes, the sign of what?
Oh, okay.
Okay, that's not quite a pronoun, but it's not derivative specific. So you need to say because the derivative changes. Okay?
What I still say? Was after school today?
Mhm.
Okay. Just make
You got it back, but you needed feedback. So did you study that? The justifications?
Yeah.
Okay.